Right. Hey, Herman, how are you?
Hey Evgeny, I'm good. How are you doing?
All good. Hi, everyone. I'm Evgeny, founder and CEO at CloudQuery. Herman, I'll let you introduce yourself.
Hi everyone, I'm Herman. I'm a senior software engineer at CloudQuery.
All right.
Now,
Yeah, go ahead. Sorry.
now I see over here in the script that today we're talking about an infrastructure data platform, Evgeny. I've been a data platform engineer for a while now, but I haven't heard this term before. Like, why is this the topic today?
Yeah. The topic is infrastructure data platform or how to build one. I think it's a term that I coined and I invented because our industry loves new terms. It's a bit similar like to customer data platform in the marketing world, where you have tons of SaaS services, like marketing services like Google Analytics, Facebook Analytics, and then data engineer or data analysts get all the data from those APIs to a database or like data warehouse, data lake, and then perform more of the analysis there. So like similar thing is now happening in the infrastructure world where you have like AWS with more than 1,000 APIs. Same thing like with GCP, Azure, and all other things like uh, uh, infrastructure SaaS apps like Vercel, PagerDuty, and like the list goes on. So
Right.
if you if you want to like perform any analysis, you actually want to do it in a database. Um, as simple as that. So yeah, it's infrastructure data platform instead of customer data platform.
Okay, so you're loading your infrastructure data into a database or a data lake or data warehouse or whatever the case may be. Now, okay, so why do we need that? Why do we want to have infrastructure data available?
Yeah, so I guess it really depends on the use case and what you want to achieve. Like I don't think you like need to build an infrastructure data platform from your day one in the cloud. But usually as cloud accounts grow, what we saw like in the last couple of years, there are a lot of use cases like asset inventory or like running security checks. Like there are products that call like CSPMs, security posture management, or understanding cost better. So there are a lot of small use cases, but actually, like each of those use cases eventually is what it does is querying the data to get some new insights. Right? So for asset inventory,
Right.
you want to query like all your assets across all regions or across specific type. So at the end of the day, it just queries the data. So yeah, you have like a couple of options, right? So you either buy a product that does that, or you just do it yourself, and then you have all the flexibility.
Okay, I see. No, so a lot of those use cases you mentioned there, like some are like cost optimization, some are security related. They kind of span over different teams, it seems. So I guess what I'm hearing is it makes sense to for one team to load all this data into one place and then everyone gets to benefit from it. Is that right?
Yeah, I think it's one way to like it's one good way to structure it. So like for a platform team or a DevOps team to kind of have those ELT workloads, like or the workloads that load the data from the API to the database. So they set it up and make sure like it runs on a daily basis, and then everyone can access the DB and do new views, do transformations, connect it to various like dashboards or visualization tools. But yeah, like at the end of the day, you can also like if you have a number of teams, if the organization is big enough, you can set up two workloads. That
Yeah.
like it really depends on the team. So usually it's relatively easy to set up the workloads as well. So yeah.
Interesting. Interesting. So it sounds like you're telling me that you're essentially applying the modern data stack like, of extract and load transform, but instead of customer data, we're now talking about infrastructure data. Uh, why? Like this idea has been around for a long time of loading things, extracting and loading. Why is this? Why didn't this happen in the infrastructure space until now?
Yeah, yeah, it's a good question, and like probably I don't have the ultimate answer. Like it can happen because of multiple reasons. Why it takes time for one industry to evolve like slower than the other. Um, I guess it's because of like number of things. One, the cloud infrastructure is a newer thing than the marketing thing. It was created later on. So that's one reason.
Yes.
And
Mm.
the other one, there is also a paradox in the like in the whole like security asset inventory use cases and vendors that actually what they were selling is an implementation of the modern data stack. So a vendor can tell you, okay, we're implementing a modern data stack and now you need to pay for it because then he is not a data vendor, right? Then he will go to a data vendor, right?
Okay.
So
Yeah.
there, so you can, the industry kind of like I think was hiding it for a bit, but eventually it gets uncovered, and you just apply the best spec that's possible.
Now these vendors that companies were using until now, they kind of bundled everything together into a single platform, right? And then just gave you the ability to query it. So that sounds pretty good. Like why do we need to unbundle things and run it on our own when we can just pay some money for a third party to do it for us?
Yeah. So I guess like it isn't actually a bad idea, or it wasn't a bad idea at the beginning when the cloud started, and no one was sure like where the cloud will really go and what it will turn into. So like when AWS started, you had two APIs like S3 and compute, and that's it. So it made sense at the time. Then okay, you have one thing that monitors all the APIs, like takes care of all the possible APIs that AWS releases, does the
Mm.
visualization, or like give you kind of like all the options that you can visualize S3 like metadata or how many buckets you have, and then yeah, like it works. But the problem that it's really turned into kind of like a monster in terms of number of APIs. So it really turned into the modern data stack, right? Where you can't really have one vendor that maintains all the APIs, gives you all the options of all the visualization in the world,
Mm.
creates, maintains a query language, right? And it kind of like it has to be unbundled. So you have one vendor that focus on uh, getting the data, one vendor that focus on visualization, like Grafana, like Preset, and one vendor that is for storing the data um, and, and querying.
I see. So it's like the problem has just grown in complexity over the years, and it's now gotten to a point where it's not feasible for one single vendor to offer a quality solution that covers all these different aspects. Is that right?
Yeah, exactly. It's
Okay.
yeah, it's not possible. Like it happens in the industry in many cases. Yeah, it's not possible to solve this problem in one way, and you have to like unbundle and have solutions that focused on specific problems because they're too big already.
Yeah, yeah. Now, let's talk about cost. If we have this many APIs and tons of data, uh, will we be saving money by storing all this ourselves, or how does it compare to previous solutions?
So I think in terms of cost like of storing just having the data, so I think it's like in terms of cost of having such a like a modern data stack architecture for infrastructure data platform, it's like as cheap as it can get. Like a vendor is if a vendor is implementing it for you, then he will have to pay the same thing because you have to pay mostly for two things. One thing is getting the data out of the APIs and putting it and loading into some database or even like data lake, like remote storage. It has 3 buckets or GCS. So it's the compute workload. So the more efficient your like ELT workload, the less money it will cost you to get the data out. And then just for the storage. So if you put it in S3 or in the database, like you will pay for that storage or for that database. And it's relatively cheap. Like those solutions, like they advanced pretty well in the last couple of years, because like in the database was also unbundled, like with storage and compute. So basically you just pay for the storage, and then you pay only for the queries when you run them, which is nice, because usually you don't, like in a lot of those use cases, you just want to like run a few queries when you want to analyze something. So you just pay for that, and the storage is cheap.
Okay, yeah. So it sounds like it should be a lot cheaper than previous vendor-based all-in-one solutions. So that's a definite benefit, at least. Now, okay, seems pretty simple, I guess. You get the data out of the API, transform it to some schema, put it in a database, and then you can ask questions with SQL. Why did we use like CSPM solutions in the security space and all those other acronyms until now?
Yeah, I guess it's a good question. I think, as I said, like it was the industry was confusing and it evolved a bit slower than in the marketing space. But I think the good news is we can do it yourself now, save a bunch of money, and get like pro access to our data, and I think have lots of fun. So yeah,
Yeah.
let's demo it and really show how simple it is to build it yourself.
Okay. Yeah, sounds good. I'm pretty excited to show everyone what we can do. So am I sharing my screen now? No.
No,
Can
okay.
you? Do I need to turn that on? Maybe I need to turn that on.
Yeah, yeah.
Okay. Yeah. Can you see my screen now?
Yeah.
All right. Okay. So I guess for a little demo to show what we can do, we'll download CloudQuery, the CLI, which will then configure a little bit and tell it to download some data from the AWS APIs and load it into a database. I think in this case we'll maybe just use Postgres or S3. What do we want to use? I don't know.
Yeah, we can use just Postgres for the
Let's use
sake of
Postgres.
simplicity,
Yeah,
and
that should be
maybe
simple enough.
and maybe just like a quick uh like um recap of what is CloudQuery, or what component in the modern data stack it does, right? So CloudQuery is the component that loads your data into any database. So it loads your data from pretty large number of source plugins that we maintain, and we have some community plugins, and you can also develop your own. But that's what it does. It gets the data out of the API as fast as possible and puts it into any destination. So yeah, with that, yeah, Herman.
Exactly.
Is
So let's see here. I'm on the homepage now. I'm going to try and use our website to do this. So I'm going to copy the command from to brew install CloudQuery. Let's run this over here. I already have it installed, but it should do something. Please tell me that it was successful. I should turn this off, actually. Auto updating homebrew. that's not what I wanted to do.
You can also download it. You can also download it with wget, like for Linux, because CloudQuery isn't written in Go, so you get the benefits of
That's a good point.
single
Yeah,
binary,
it
single
works on,
binary for.
it works on any platform. Okay, so going back to the website here, let's click on Get Started. See what it is about. Okay, yeah, here it says the brew install command, and then it's telling us how to configure a destination. So a destination in our case will be Postgres, and it looks like the configuration we have here is quite handy because that's what we want to do. So I'll create a little directory. We'll try and run this. And let me create a file for the Postgres destination. And we'll just paste. Ooh, it's very big. We'll just paste the config in here. Now, I have to change some of these connection settings a little bit. I think I have this already. It should work, but I have a database that has a different name. Okay. You can also use environment variables, like it says here. You can use like PG connection string, which is probably what you want to do in most cases. And the rest looks fine. I think it's pretty standard. We just want to put our data into Postgres. So let's save that. Okay, inside here we now have a Postgres configuration file. Let's go back to the website, have a look at the source. So the source in our case here is AWS. So we want to load data from some AWS APIs. I'm going to copy this again, but I'm going to modify it a little bit because, like we said earlier, AWS has thousands of APIs. We probably don't have time in this video to watch it, download all of that. So we're going to just narrow it down to some subset of APIs, maybe. So let's do, let's see. Yeah, so over here in the destinations, we're going to send it to the Postgres destination that we just set up. And here's a tables setting. Now, tables in CloudQuery world that's what we call like a single API result, or the results for a single API. So what do you want to limit it to, Evgeny? Shall we say limit it to S3 tables, maybe?
Yeah, we can just limit it to.
You can do something
S3.
like this.
Yeah.
And then it'll only download the S3 related resources. Okay.
And maybe you can, maybe you can show also like where are all the list of all tables available for each plugin.
That's a good point. Yeah, I of course am quite familiar with this, but let me go back. So over here on the website, you can go to plugins. So there are sources and destinations. We've already set up the Postgres destination. So let's go to the sources, AWS, and an overview. Yeah, here you'll get a lot more information about authentication and so on. We'll need that in a second. But mostly, if you're authenticated with the AWS CLI already, then it should just work. Or similarly, if you're running this on an EC2 instance, then it should just work. Now, over here on the left-hand side, there's a tables link. So this lists all the available tables. I'm going to scroll through it here just to show you how many there are. It goes on and on and on. And yeah, that will take some time to download if you have a large cloud estate. But we're gonna just limit it to AWS S3. So I typed AWS S3 star in our config. So we're gonna get these tables, accounts, buckets, and some configuration around the buckets. Okay. Let's look at that file again quickly. Just check that it's right. Yeah, I think that's all we really need. So let's check that we can run the CloudQuery command now. Yep, we can. There's the help. So what we'll do is we'll do CloudQuery sync AWS, so that's the source, and we want to sync it to Postgres, and then we just run it. Let's see what happens. Oh, okay, PG connection string. Ooh, that's interesting, actually. That's a bug we should fix. Because it's a known bug, but we need to address that. Because over here in the Postgres configuration, we have this connection string as an example, but because I don't actually have that set, it's erroring out. So let's just delete that line and then try again. I did forget one thing. I forgot to authenticate. So let me make sure I am authenticated. I'm going to do SSO login. Hopefully this works. Let's see. It's taking longer than usual.
Yeah, I think you definitely want to have an SSO for your AWS.
Yeah, I'm not sure why it's taking so long today. There we go. There we go. Thanks, AWS. Okay, now we're logged in. And I'll go back to the terminal. So now everything should work, I believe. Let's works. CloudQuery, sync, AWS, Postgres, go. All right, there we go. So now what it's doing is it's downloading the AWS plugin that we specified. And after that, it'll download the Postgres plugin that we specified. That's because CloudQuery is written with a very pluggable architecture. You download the CLI separately from whatever plugins you want to use with the CLI. This also means that if you need to extract data from some other source that we don't support today, you can quite easily write a plugin yourself and hook that up to the CLI and get that data into whatever database you like. So it's taking a bit longer because I think my connection is maxed out.
Yeah, and I think also, like, if you write a plugin, you can also host it in, like, we don't have any registry. So basically we use, you can maintain the plugin in your own GitHub repo, and like, you just use the GitHub releases. So we just use the GitHub, like, as CloudQuery registry, similar to Brew. So yeah, it's quite easy to really maintain your own plugin.
That's if you want to make it public. All right, before we continue that conversation, we ran into a problem here. I already had a database with that name, and now we have some migration issues. Now, usually you won't run into this, but let's, what's the easiest way to fix this? If we connect to a different database, drop the Postgres, drop the CloudQuery database. Now, there we go, and then create database, CloudQuery. I did cheat a bit in my demo because I already had that step done locally. Okay, now if we run it again, it should hopefully create the tables for us, and we'll be able to query them afterwards.
It also caches the plugin, so it doesn't download it it just downloads it once in your first run.
That's good to know. Yeah. All right, that was quick. It says here it downloaded 21 resources, so that would be in total across all the tables, not necessarily the number of buckets we have. Let's count the number of buckets we have for now. Let's see, select count from AWS S3 buckets. Did I mistype that? Oh no, I'm connected to the wrong database. Connect to the CloudQuery database, and now count buckets. Okay, so we have 8 buckets. Let's see some information about them. Yeah, here we go. So we've listed all our buckets. Quite a bit of information about them. We can also go query the policies now, or the configuration, or whatever we like. But that's a very quick demo of what you can do with CloudQuery. And as you can see, it was fairly quick to set up. A few road bumps along the way, but nothing too bad.
Nice. Yeah, I think that's a really good demo, and yeah, I think that's like as easy as it gets. You have all the data. You can use standard query languages for whatever database you are used to or you want to use, and yeah, then you can connect it to Grafana or preset, like shared dashboards, like use the features of and the sharing features of those visualization tools, like to share it between teams, and like create complex views or transformation with other tools like DBT. Yeah, that's
Exactly.
the heavy loading was done by CloudQuery, loading the data in the most performant way we were able to do. So yeah, I think that's mostly it.
Yeah, that's it. That's it. Yeah, of course. Like after you've loaded your data into Postgres or S3 or whatever you want, then like you said, you'll rely on some different tools to do transformations. CloudQuery doesn't do that for you. What it does do is it allows you to specify the subset of tables that you're interested in. But then we believe, like with the decoupled modern data stack, it's a good idea to first load all your data and then perform transformations later, because your transformation requirements may change. So it's good to have the raw data available somewhere. Yeah, I think that's it
Yeah.
for today. Thanks a lot for the discussion, Evgeny, and answering all my questions. That was really interesting.
Thanks everyone for the great demo,
Yeah,
and yeah, I'm looking forward for more discussions on on the cloud query and maybe writing some plugins in the future. So
yes, that'd be great. Yeah, I'm looking forward to it.
all right,
All right, talk to you soon.
bye.
Bye.